Problem 41. Okay, we have a function and it is not defined at s equal to 1. So the function looks like this. And here I have 0 when s is equal to 1 or minus 1. And it says that we should define the function at point s equal to 1 so that the resulting one is continuous at that point. So here, what is the domain of f? So it is the set, right? Or maybe I should write it like this. And we want to extend the domain of the function such that we add the point s equal to 1. So we want to extend this set to this set. So extend the domain of f. To do that, we will define f at 1. So that f will be continuous. How can we do that? When is f continuous? F is continuous at x equal to 1 means that we have a limit there. Let's say it exists. And the value of the function at that point is equal to the limit. So what is the limit? Let's check that. Instead of s cubed minus 1 over s squared minus 1, I will just use their factors. As x goes to 1, what we always assume that s is also not equal to 1, right? So we can cancel these two and just plug in 1 to get 3 over 2. So we have to define, this is what we have to do, f1 as 3 over 2. So we already have a limit. So this first condition is already true. So the second condition to check this one, we have to define f1 as 3 over 2 to extend it continuously. What about the point s equal to minus 1? Can you add something there so that f is continuous? That you cannot do. You can check the limit of this function as s goes to minus 1. From right and from left, you will get different values. One of them is going to be plus infinity and the other one is going to be minus infinity. Actually, you're not even getting a value. The right-hand side and the left-hand side limits, they don't exist. So the limit does not exist and you cannot do anything for that limit to exist, right? So you cannot do anything to make f continuous at s equal to minus 1. But for s equal to 1, we have a limit. So actually, this function looks like something like this, right? And we are just filling this point. This is s equal to 1. But at x equal to minus 1, for example, this is how the function looks like. Or maybe other way around, but I mean, you get the idea. So you cannot add some point here to make it continuous. And I leave it as an exercise for you to check the right-hand side and the left-hand side limits at s equal to minus 1.